In this problem, we want to compute the position x of t, and we are given the velocity v of t. So this is the expression for velocity, and we are also given that at t is equal to 0, the particle is at x equals x naught. So how do we do this? We always start with the relation between velocity and position. So we know that dx is equal to v dt. This is the relation, v dt, not v dx. My apologies. V dt, right? And so this is the relation between position and velocity. And so if we want to get position and we have dx, what we need to do is we need to integrate. So we're going to integrate on both sides of the equation. And I'm always integrating from the beginning of the story to the end of the story. So I am just marking these integrals. I am marking these limits here as initial and final just to remind myself that that's what I'm going to do. And notice on the left hand side, I'm going to have an integral that is over position, dx. So my integration variable is x. So when I go to the next line and I put in my proper integration limit, well, at the beginning of the story, the value of x is x naught. So that's going to be x naught. At the end of the story, well, it's going to be xf, the final position, whatever it is. So that's going to be the integral on the left-hand side. And on the integral on the right-hand side, what am I going to get? Well, at the beginning of the story, the initial time is the integration variable. So the initial time is 0. So the bottom limit is 0. And the final time is tf, whatever it is. So v of t dt. And so I'm going to go ahead and plug in the expression that I have for the velocity as a function of time. That's going to be v naught times t over tau to the n dt. And so in going from here to here, all I've done is plug in this formula. Okay, so that's what we have. And let's go ahead and do these integrals. So let me start with this integral over here. This integral is just going to be the integral of dx. Well, that's just x evaluated between x naught and xf. And this bit is going to be equal to xf minus x naught. So the left-hand side is going to be xf minus x naught. What about this integral? Let's try going through this integral. This thing is a constant, so it's going to come out. So I'm going to have v naught, and then I'm going to have the integral from 0 to tf of t over tau to the n dt. Okay, and I could go ahead and pull out the tau because it's a constant, but if this was not t to the n, but something like the exponential function or the logarithm or something like that, then it would be a little bit harder to do that, right? You couldn't really do that. So what we're going to do is we're going to do something else. We're going to do u substitution, because if this whole thing was just x, right, and we were integrating over x, then that would be a really easy integral to do, right? Like we know how to integrate x to the n. So let's go ahead and make a u substitution, right? So I'm going to say that u is equal to t over tau. And this tells me that du is equal to dt over tau. And in particular, it means that tau du is equal to dt. So with this u substitution, this integral over here, so let's call this integral I. This integral I is going to be v naught times the integral. Well, this bit over here is now just u. So I'm going to get u to the n. For dt, I have that dt is equal to tau du. So that's what I'm going to put in. So I'm going to put in here tau du. And the thing that I have to take care of is the limits, right? So when t is equal to 0, u is also going to be equal to 0. So the lower limit is 0. The upper limit is going to be the final value of u. Well, when t has a value tf, u is going to have a value of tf over tau. So that's going to be my upper limit, tf over tau. Yeah? Okay, so now I have v naught. I'm going to bring out the tau, right? And I have the integral from 0 to tf over tau of un du. And this is an integral that I know how to do. So the way that I usually do these integrals is that I know this is going to look something like u to the n plus 1. But if I take the derivative of u to the n plus 1, I'm going to get a factor of n plus 1 in the front, which I don't really want because there's no factor of n plus 1 here. So what I'm going to have to do is I'm going to have to divide by 1 over n plus 1. And so this whole thing now is the integral of u to the n. And this is going to be evaluated between 0 and tf over tau. So I evaluate this bit, v naught tau, and then I have 1 over n plus 1 times tf over tau to the n plus 1 minus 0, because when u is 0, this whole bit is going to be 0, and so this tells me that this integral is v naught tau over n plus 1 times tf over tau to the n plus 1. Okay, so I have done the integral on the left-hand side, and I have done the integral on the right-hand side, and so I'm going to go ahead and plug it in. The left-hand side, I was left with xf minus x naught. That's this result over here. And for the integral on the right-hand side, that's this result over here. So this is equal to v naught tau n plus 1 tf over tau to the n plus 1. And so I can just move the x naught to the other side and have what the final position is. Now, the thing that I want you to notice when I have this expression over here is that tf could be anything we want, right? So since tf could be anything we want, we could actually just set tf equal to t. And if we do that, that is telling me that x at time t is equal to x naught plus v naught tau over n plus 1, right? And this is my final solution. Okay? Thing that I want you guys to really pay attention to. The thing that I'm going to care about the most is you being able to set these integrals correctly. So these 3 lines right here are going to be 90% of what I'm grading. Okay? This is the really important part. You start from the relation between position and velocity. You go from the relation of position and velocity. You go ahead and integrate. You go from the beginning of the story to the end of the story. And you use the fact that you know what your integration variables are to set the limits, right? At the beginning of the story, x is equal to x naught, so that's my lower limit. At the end of the story, x is equal to xf, so that's my upper limit. On this side, t is my integration variable. At the beginning of the story, t is 0, so I get a 0 here. At the end of the story, it's the final time, tf, so that goes over here, right? And then I go ahead and put this in here. Everything that happened from here and below, all of this stuff, so all of this stuff that you see here, this is me just doing an integral, right? So this is what you're learning in your calculus class. This is just doing integrals. It's a whole bunch of algebra. You need to know how to do it, but that's not really the point of a physics class, right? This is something that you learn in calculus. You should be comfortable with it. If you're not, you should practice it some, right? But this part over here, setting up these integrals, making sure that your limits are correct, that's the thing that I really, really care about. Okay?